Hello, I'm Ronny Robbrecht, and I'm here to welcome you to the exciting world of Apple Macintosh connectivity. Ever since Apple Computer introduced the Macintosh in 1984, our goals have remained the same. We want to give individuals powerful personal computing technology that fundamentally transforms the way they think, work, learn, and communicate. In 1988 to 89, Apple Computer and DEC made a joint commitment to merge the strengths of the Macintosh and VAX environments. We recently announced an alliance with IBM in a joint software company to produce the operating systems of the future, offering major new user and system functionality. These moves are external signs of Apple's clear commitment to major corporate and institutional accounts. Less visible, but vitally important, is our record of innovative solutions to enhance the efficiency of existing and future investments in technology and people. This video deals with something you may not be aware of, the far-reaching progress Apple Computer has made in bringing personal computer connectivity into multi-vendor networking environments. In this video, Apple Computer and some of our major customers tell you why we believe the Macintosh is the computer with the versatility and connectivity to help you solve your information system problems and achieve better networking services. We shall discuss the question of connectivity in detail. Then we'll look at Apple's goals of seamless integration across extensive networks without people using the system needing to know the underlying processes. We shall see how the Macintosh architecture achieves this goal, giving users the benefits of screens and formats they know and feel happy working with. We'll show how the Macintosh provides a consistent, familiar, user-friendly desktop environment, whatever the host services or applications, whatever data are being accessed and processed, whatever operating systems are supplying the processing power. But you won't hear all this just from us. We'll let Apple customers tell you in their own words how much the Macintosh has enhanced their MIS performance. The MIS manager you will see and hear are here responsible for the efficiency of services provided over integrated multi-vendor networks to some of the largest companies in America. For organizations operating multinationally like these, efficiency is a vital factor in their success and prosperity in highly competitive, efficiency-driven markets. Ensuring maximum benefit from MIS investments is key to their future survival. So their experience is extensive, their problems substantial. The Macintosh has helped them, and this video will show how the Macintosh can help you too. First though, let's hear what people in some of the largest businesses say about the Apple Computer experience.
This has been a total turnaround. The clients, the users, they're asking to be trained, and they're wanting to broaden their skills. The horizons have opened up. That's what the Macintosh does best. It enables a user. They empower themselves.
I was surprised in the Mac's connectivity, not only to the mainframe, but to our backbone, Ethernet backbone, to reach out and touch some of our back systems in the bowels of manufacturing. That was a pleasant surprise. And we're going to be exploring that type of connectivity much more rigorously than we had in the past.
The combination of using a RISC-based Unix server that's very fast and dependable on the server side with the high-speed performance of the TCP/IP network with the Macintosh as the user front end is really a winning combination for us.
But you can't have a large computer in every part of the laboratory. Instead, we have Macintoshes on desktops and on benchtops to connect into the larger machines. we can put all of the computers, almost like virtual terminals, onto the Macintosh desktop. We can have a sun in one window. We can have the Cray in another window. Unix machines aren't simple and easy to use. The Macintosh is intuitive. That's how it was designed. It has a desktop that looks like your desk. Every Macintosh machine can use the TCP/IP services, from the Classic up to the Macintosh 2FX.
My view is the user shouldn't care where the data is as long as he gets it and he can do something with it. We've got more data than we know what to do with, right? So now you talk about, okay, now how do you bring that to the desktop so that I can do something with it? The whole idea is you get the stuff into people's hands, they'll use it. You know, give them the tools, teach them how to use it, and encourage them. There's tons of bright people out there. But I don't want them to be computer scientists. I want them to be the most innovative, customer-oriented bankers in the universe.
As you've just heard, Apple customers can be enthusiastic in their praise of the Macintosh performance. But before we look at specific cases in detail, here's Russ Christoph, your guide during this video. He will start by explaining Apple Computer's approach to connectivity.
I'm Russ Christoph, and today we'll be discussing the subject of personal computer connectivity into multi-vendor networking environments. We'll show you why we believe that Apple Macintosh is the best connected personal computer available today. First, we'll spend a few minutes discussing Apple's perspective and strategy on multi-vendor integration. We'll look at how Macintosh integrates major protocols and networking standards to deliver diverse network services into a consistent user environment. Then we'll visit with IS managers from around the country. You'll see how large organizations use Macintosh to connect and integrate multi-vendor networks to provide users with enhanced access to valuable data and applications. We think that you'll find useful information throughout this seminar. However, if you want to go to a particular section, the printed guide in your seminar package will help you fast forward to that segment. This seminar is about harnessing the power of information systems and networks to enhance the productivity of individuals and the overall effectiveness of your organization. And it's about the role that Apple Macintosh can play in achieving those objectives. So let's outline some basic requirements for an ideal personal computer in a multi-vendor network environment. First of all, networking should be an integral part of a personal computer's hardware and software architecture. When the personal computer is designed from the start with a modular architecture, you can easily extend the system to transparently support major multi-vendor networking standards like SNA, DECnet, and TCP. What's more, a flexible personal computer architecture allows you to deliver a broad range of network services in a uniform, cost-effective manner. So network functions feel like a natural extension of the user's own desktop computer system. And the users can learn to work with the network quickly and use data and services successfully. When personal computer networks are easy to set up and configure, life is easier for users and for IS. Finally, an ideal personal computer for multi-vendor environments must provide a range of integration options. For example, in some situations, you might provide access to existing host applications using terminal emulation. For other applications, software front ends can simplify access to existing systems. And for new applications, you'll need tools to build distributed databases and other cooperative processing systems. Now, as you may have guessed, Macintosh satisfies these very important requirements for effective network computing. One reason is our basic design. Macintosh architecture easily fits into major environments. It adapts to changing standards and makes network resources as easy to use as local ones.
We've invested very, very heavily over the last 2 or 3 years in standards like TCP/IP-based networking. We're making a major investment with the Apple Digital relationship in DECnet and with making AppleTalk work with VAX VMS systems. We made a major investment in SNA connectivity to make the Macintosh work better with IBM host systems. The architecture of the Macintosh that we talk about on the operating system side is a 5-layer architecture, an architecture that includes a toolbox layer and a desktop layer that are higher levels than the typical operating system, a toolbox layer so that it's possible for software vendors to use a consistent set of tools to put networking capability into their applications, and then a desktop layer to make the user's experience of choosing a network, of configuring a network, of deciding which resources to share uniform and consistent. So the user sees all of those kinds of files in exactly the same way on their desktop. They choose them the same way, they work with them the same way, and for networking it provides a very uniform, smooth user experience. I can have up on my screen information that came from a VAX, information that came from a DB2 database on a mainframe, information that came locally from a word processing document on my machine, and I can use the cut and paste capabilities of the Macintosh to combine all of those in a spreadsheet, build a graph based on the results. I can do that kind of thing because the operating system, because the Macintosh itself, supports that. So the tools don't have to have been designed to work together in order for me to use them together very, very effectively. It's one of the advantages of the Mac experience.
The AppleTalk network system extends this common user experience across a network. Let me take a moment to clarify some terms. AppleTalk is a complete network system that includes a full set of services and protocols, as well as interface standards for presenting information about network resources to users. The AppleTalk network system is an integral part of Macintosh system software. The speed of data moving through a network is determined by the physical medium, not by the AppleTalk protocols. AppleTalk operates over a variety of standard networks, including IBM-compatible Token Ring. On Ethernet, AppleTalk runs at the full 10 megabits per second. It even runs across 100 megabit per second FDDI links. When running with LocalTalk, the convenient network hardware built into every Macintosh, AppleTalk runs at about 230 kilobits per second. So to provide local wiring for a small work group that exchanges files and electronic mail, you can start with LocalTalk. Then, as your network increases in size or traffic, you have the option to switch to another network type. Upgrading a network is simply a matter of plugging in a connector or a card and selecting the new network type from a menu. And the result is absolutely consistent and transparent to your users. The only way they know that they've moved on to a faster network is that things get done more quickly. Macintosh networks are easy to set up and to upgrade because we build connectivity directly into the toolbox layer of the Macintosh architecture. That's where we provide support for diverse network types. The modular architecture of Macintosh allows us to incorporate new communication standards as they emerge, while protecting your investment in existing applications and end-user training. In the next segment, we'll visit the first of the 5 organizations we saw earlier. We'll take a closer look at how the IS group at a large utility uses AppleTalk products and services to tighten the relationship between people and information. If you'd like to skip to a different segment, fast forward until you see the title. In many ways, connecting a new client to your network is a lot like hiring a new employee. When you bring someone into your work group, you expect them to fit into the office without disrupting people or systems. Above all, they've got to be productive and easy to manage. When you connect Macintosh to your existing local area network, you expect the same things. And that's the expectation that Apple's networking strategy is designed to fulfill. As we've seen, designed-in AppleTalk makes networks easy to use and easy to install. It offers a simple way to scale up and extend networks, and it offers an efficient way to integrate with multi-vendor environments. One key part of AppleTalk, Apple Filing Protocol, or AFP, provides a common standard for multi-vendor connectivity. Products such as Novell NetWare, Digital Pathworks, and many others incorporate AFP. With AppleShare and other AFP-compliant servers, users access files across a network just as they would on a standalone Macintosh. And with optional software, DOS users can do the same. Macintosh integrates with all major LAN environments, including Novell, 3Com, and Banyan. Apple licenses AppleTalk to other vendors as an open standard. For example, Farallon offers a series of products for integrating IBM-compatible PCs into an AppleTalk network. and Novell has integrated AppleTalk into NetWare. So Macintosh users can exchange files with DOS-based personal computers, take advantage of NetWare security and backup, and access VAX VMS files, all with the consistent Macintosh user interface. Users see files and directories stored on the NetWare server as standard Macintosh files and folders. Macintosh users also can access PC files, and DOS and OS/2 users can access Macintosh files. This enables PC and Macintosh users to work together more closely. Let me show you some of the ways that AppleTalk can simplify managing and using a network. As each node becomes active, AppleTalk assigns the user a network address automatically. Administrators can choose easy-to-remember device names, and they can logically group devices into zones to help everyone make sense of what's on a large internet. And with the AppleTalk Internet Router, AppleTalk makes optimal use of network resources. It sends routing information only when and where it's needed, making Macintosh work more efficiently than ever in multi-protocol environments. The bottom line is flexibility, to adapt and to enhance what's already in place. At Southern California Edison, the nation's second largest utility, Macintosh integrates local area networks and mainframe resources.
As a company, we have nearly 17,000 employees, an asset base of over $15 billion, and annual revenues of roughly $6.5 billion. The information systems have to be designed to be cost competitive. And in fact, if they can help us become even more cost competitive by allowing a better exchange of information and a flattening of the organization, which we've seen in the last 5 years, this is an important step for us. When we started connecting Macintoshes together, whether through the mainframe or through local area networks, it became a much more valuable tool because now, besides simply allowing me to do my day-to-day business, it allows me to interact and communicate with other people within the company.
The Macintosh is a very good network device because of the built-in networking that it has. Because we started installing Macintoshes some years ago, before our token ring network was implemented here at Edison, we have a lot of devices that simply have a 3270 connection. We've got an infrastructure in place now with a fiber optic backbone running at 16 megabits in this campus area, but we predominantly use the token ring network. We do have some areas that use Ethernet for specialized functions in an engineering area and at some of our power plants. And we're able to connect Macintoshes and using the Internet router, get them from the Ethernet network into token ring if necessary. I think one of the real strong points of using the Mac on the token ring is that we're able to use the Internet router and bring in the whole range of network services as if they were directly token ring attached. And we have a lot of cases where both PCs and Macintoshes are coexisting on the same LAN and are able to get to common network services, such as our host gateway devices.
In our company, the Southern California Edison Company, token ring is a standard, and it's an IBM standard. But it just so happens that Macintosh connects to the standard very, very nicely. When the IBM environment was in this department, we've found that it took a force of people to try and just keep a network moving. We were sharing peripherals with the IBM system, and we were going on to some network environments, and the network would go down, and we need a specialist to come and try to rebuild the file server or retrain someone on how to use it. Well, there aren't enough people, there aren't enough time, there isn't enough money to support those kinds of network environments in this department.
I think the Macintosh really makes a good workstation on our network just because of the visual orientation. It's very easy to pull up the chooser and just see a list of all the zones and the different servers, and if you want to attach to one of them, you simply click on it and it shows up. There is some security involved and you may have to supply a password, but it's visually oriented, it's very easy to select and mount servers. A lot of the networks at Edison are using Novell NetWare as their operating system, and we have both PCs and Macintoshes tied into the NetWare servers. That's worked out very well. We're able to use Novell's NetWare server software to exchange files relatively easily. NetWare supports both IBM and a Macintosh client, and we simply mount the Novell server as we would mount an AppleShare server, and from the Macintosh just drag a file across and it copies it, and then people that are connected to the same server via token ring on the PC are able to pull it up right away. And the converse is true as well. I think it's because of Apple's open architecture that we have the confidence that it's going to play really in whatever arena that we're running a year to 3 years out. And as we build our network infrastructure, I think the Macintosh will grow along with us.
As the uses of IBM and plug-compatible hosts evolve, we know one thing won't change. Today's networking architecture, SNA, will remain an important standard. The network client has to fit into that world and connect in the optimal way. And it must be ready for what we already know and anticipate about SAA. What's essential in connecting to IBM host environments is this: rich, cost-effective communication with mainframe and mid-range systems, and advanced connectivity for emerging cooperative applications. On the physical level, playing in IBM host environments means support for these standard connections. By now, you won't be surprised to know that Macintosh is compatible with all these protocols and links. More importantly, Macintosh can deliver high-performance sessions and file services and support cooperative applications at low cost and high efficiency. Macintosh architecture makes all this possible. Let's say the Macintosh user clicks on a Connect button in the desktop or presentation layer. That sends a request to the toolbox level, where we build in the protocols, architectures, and interfaces that link with SNA and SAA. The toolbox issues an open session call to the host. You can modify the call or make other changes on this layer without changing what the user sees in this layer. That's how Macintosh works with SNA in such a powerful and consistent way. At Eastman Kodak Company, Macintosh gives end users unprecedented access to IMS, Datacom DB, and DB2 databases.
Kodak uses traditional mainframe computers and host-based processing for large operational and informational systems. It has over 35,000 PCs and Macintosh systems within the Rochester unit, and probably that exceeds 45,000 worldwide. Basically, to our surprise, there isn't anything that the Mac can't connect to, either directly or through our Ethernet backbone, which runs extensively throughout the corporation. An advantage of Macintosh is the homogeneous and a singular visual environment. In the Mac, we have a consistent, robust, well-controlled operating environment that's easy to use, easy to learn, and easy to support. We also have a set of software, a growing set of software that allows interconnectivity to the things that we need to be interconnected to in a way that's transparent to the end user.
The network is right in the Mac operating system. It's not an add-on program that you're running. So as a result, when I pull down the chooser on a Mac, I can see the hosts that I can connect to, and I'm totally oblivious to the medium. I don't have to know whether I'm on Ethernet. I don't have to know what the host number is. I'm not dealing at a level like that. I'm merely dealing with documents and things that I'm already familiar with that are running on my existing hard drive or on a floppy disk. So the complexity of the access has been hidden.
When Macintosh is used for terminal emulation, connecting to the host and running applications can be greatly simplified.
You connect a Macintosh computer to the IBM network in exactly the same way you would connect an IBM PC. What you need to access a mainframe session from a Macintosh is an interface card or a protocol converter. What these devices, either hardware or software devices, do is they emulate a 3270 terminal.
And once you're connected, Macintosh can make mainframe resources easier to use. At Kodak, HyperCard-based software robots automate routine tasks and help the users make the most of existing systems, even older, harder-to-use IMS databases.
Although there's a tremendous energy around moving new databases to DB2, the reality is today we're stuck with a lot of the data being on IMS. And so we've had to create tools that would allow end users to access that data and bring it into the real world where they can use it in spreadsheets and in word processing. Software robots are basically programs that emulate what a human does at a keyboard. They're able to send keystrokes, they're able to see the events that are happening on the screen and take appropriate action. Normally with a mainframe system, you go through 9 or 10 screens before you're really at the place you want to be. And you might have to put in one piece of information on 9 different screens.
Here's an example of a software robot that's made the users of an existing system more productive. Some of Kodak's employees use profs to submit their daily time records. At the end of each week, a departmental secretary checks these reports to be certain everyone has accounted for a full 40 hours and sends a prof's note to those who haven't. It's a repetitive, tedious, and time-consuming task.
And typically what a secretary will want to do either on a Friday and a Monday is to go through and enter the insurance numbers of the people in her group, and she has to go through each one, wait for the screen to be updated, and then go on to the next insurance number, etc. We automated that with a software robot, which now the secretary clicks on a button, enters their username and a password, and the software robot just goes off and enters the mainframe commands to bring up those screens and enter the insurance numbers of people. And when it's gone through everyone in the group, for the people who haven't entered 40 hours, it sends out a prof's notes and notifies them to put in their time.
Another custom application developed in little more than 2 months is Kodak's Pro Passport system. It uses HyperCard and Apple's data access language to communicate with a large DB2 database, giving users a simple and intuitive way to define queries and format reports without having to know SQL.
Pro Passport is a very large international database that profiles professional photographers. And what it presents to end users is the general ability to read, edit, delete, and do robust ad hoc queries against that database.
This is the data entry screen for the Pro Passport system. An end user wanting to put this information into DB2 from a 3270 terminal has to go through 8 screens. HyperCard allowed us to add data access language capabilities. Suddenly end users are making use of SQL without ever knowing that they're doing it. They can take data that resides in these big corporate databases and manipulate it within minutes on an application they already know how to use. Macintosh users don't want to know about DB2. They don't want to know about SNA. What they want to do is use an application like HyperCard, for instance, and have all of the complexity hidden under the bonnet. What we've been able to provide is an environment they're already familiar with, icons that they're already familiar with, and have an application formulate a query, go off to a DB2 database, extract data, format that data, send it back to HyperCard, and have that displayed in a format that they can cut and paste into Excel, into Microsoft Word, print it, manipulate it in some fashion that they know how to do already. When we began to show the prototype, we were talking to mostly MS-DOS users, IS managers, people who are very familiar with the traditional databases like DB2 and IMS. We would demonstrate the prototype and they would say things like, now what would happen if you were really connected to DB2? What would the response time be? And we would laugh and say, no, we're really connected. That is the real connection.
The Mac presents that singular, homogeneous operating environment that is easy to learn, easy to use, easy to extend. Now what we've proven and demonstrated to ourselves is that it's a robust platform to interconnect to other systems. And that's something that we've always wanted to have. When you put the two of them together, when you have that nice homogeneous operating environment, along with robust connectivity, and along with Apple's plans to continue to develop interconnections as standards evolve and mature, that's quite a package. It's quite a package for corporate America as well.
Macintosh connects to the broad spectrum of IBM host environments, and our connectivity keeps expanding. With products from Apple and from third parties, such as Avatar, you can connect Macintosh with 3270 sessions. You can also link Macintosh with APPC. With the latest gateway and emulator products, you can distribute 5250 sessions, plus APPC, over AppleTalk networks. Data Access Language, which transparently links Macintosh applications with SQL databases, now serves the CICS environment. Kodak used Data Access Language to build its photographer database application. Best of all, Macintosh combines host services and data with the advantages of the Macintosh itself. It extends the power of SNA and is ready for true cooperative applications of the future. When it comes to networking Macintosh with Digital Equipment Corporation's VAX family, we're not only making connections, we're making history. In January 1988, Apple and Digital signed an historic joint development agreement. Since then, the two companies have worked together to build a complete client-server environment for the 1990s. Already, the Apple Digital Alliance has produced a set of software packages that tightly integrate the Macintosh and AppleTalk environment with the VAX family and DECnet OSI. These are available separately or integrated in a product called PathWorks for Macintosh, which is sold and supported by Digital. Doug Kane, an industry analyst with the respected Gartner Group, has watched developments at Digital for years.
Architecturally, the two companies also now are working very closely together to ensure that each of their base architectures on their mid-range and their desktop systems respectively have a high degree of commonality, a high degree of interoperability, and willingness to support each other. And both of those tend to mean that the sorts of solutions that are in place for a digital shop will be remarkably compatible with those in place and required for supporting large Macintosh networks. So if the VAX environment is the primary shared logic environment in a company, Macintosh will be a highly effective workstation in that regard. Digital, for example, does not have an OS/2 extended edition strategy. They do not have architectural influence on the IBM standard. Rather, they have to adapt their mid-range to whatever directions IBM and Microsoft set at the desktop. In the case of Apple, however, through the Apple Digital Joint Development Agreement and that relationship, they each have an opportunity to influence each other's architectures and to ensure that their architectures interoperate most effectively.
The new connectivity products from Apple and Digital build on the strengths of each user environment. Each client on a Macintosh digital network retains its own familiar style of computing, but all of them can access virtually any Macintosh and Digital VAX resource, and the combined network services are the richest in the industry. DECnet and AppleTalk networks interoperate fully and seamlessly. Since both networks are media independent, they can share each other's wiring. You can run both protocols over Ethernet, local talk, or a combination, and through the serial port that is built into both Macintosh and Apple's LaserWriter printers, you can directly connect to a VAX or terminal server. When Macintosh users access a VAX share server, they view the directory in the familiar style of their graphical interface. VAX users can see files stored in a Macintosh Apple share server in the usual DEC format, and the same applies to PC users. Of course, system managers of both DECnet and AppleTalk networks have all the benefits of VAX resident storage, data protection, and security. Clients on either network can share peripherals, such as VAX and Apple printers. All users can take advantage of electronic mail services, such as all-in-one mail, an X400 compliant messaging system that links Macintosh, VMS, IBM Profs, and other users. And there's VMS Mail, which embraces Macintosh, VMS, and MS-DOS environments. There are several ways Macintosh users can access VAX applications. First, they can emulate a VT320 terminal. Their Macintosh can also function as a full DEC Windows and X Windows server. They can even use familiar Macintosh applications, such as spreadsheets, to access Digital's RDB and other VAX SQL databases, such as Oracle, Ingress, Sybase, or Informix. Apple's Data Access Language, or DAL, makes the queries and connections transparent. To provide enterprise-wide solutions today and tomorrow, Digital's PathWorks product supports all the functions we've just seen and more. It includes full support for VMS servers, software that gives Macintosh the functions of a DECnet end node, connectivity software, and development tools. Network software gives Macintosh complete access to the world of VMS. In fact, the VAX functions just like an AppleTalk node and participates fully on AppleTalk networks. It functions and appears on the network just like the Macintosh file server AppleShare. That's because the Apple filing protocol is built into the VAX file server, and the Apple protocol maps directly into VAX security. From the Digital Network Manager's perspective, Macintosh looks like a standard DECnet end node, and to the AppleTalk Manager, the VAX appears as an AppleTalk node. With Macintosh, you can get into VAX resident applications and access services anywhere on DECnet. And the Macintosh user can tunnel right through a DECnet wide area network to another AppleTalk network without even being aware of DECnet. That lets Macintosh users interact over long distances without leaving their familiar Macintosh environment. The Apple Digital Alliance has produced the industry's most complete range of networking tools, and those tools come together in PathWorks, which combines the strengths of Macintosh and VAX systems in a true client-server environment. Here's a demonstration of how PathWorks makes it easy to access VAX applications with a Macintosh. Using the Macintosh terminal emulator MacTerminal, we'll log on to the VAX and check our VMS mail. On the Macintosh, we're running a Microsoft Excel spreadsheet. I'm going to get some numbers from this VAX to use in this document. To do that, I'll run another terminal emulation session. This time, I'm using a predefined MacTerminal file that uses Digital's Local Area Transport, or LAT protocol, and runs over Ethernet. We use a pull-down menu to select VT320 terminal emulation. In the VAX directory, we find the file we want. I could type this in at the prompt, but to make it simple, I'll just select this text, copy it, paste it into the current command line, and enter the command. No need to key in a complicated file name. And here's the file. I'll select the figures and copy them with the command copy table. The Macintosh is now holding this data in a section of memory called the clipboard. I'll activate the Excel spreadsheet window, and we'll paste the VAX data from the clipboard into the spreadsheet. Now, using MacX, a component of PathWorks, we'll retrieve some additional data from the VAX. MacX supports DEC Windows, which is DEC's implementation of the X window environment. The figures we want are in a DEC decision file, a spreadsheet application that is supported by DEC Windows. So we can run DEC decision on our Macintosh in a MacX window. As you can see, we're running several sessions at the same time. Here's VMS Mail. Here's the other terminal emulation session through which we access the VAX-based text file, the DEC decision spreadsheet application, and our local Excel spreadsheet. With PathWorks, we can connect to any number of VAX systems and run any number of concurrent sessions. We can access VAX applications and transfer data to and from our Macintosh applications. Apple and Digital provide a complete set of products to integrate DECnet and AppleTalk and share information and resources between Macintosh and VMS environments. On digital networks, Macintosh provides an ideal foundation for client-server computing. In coming years, most of us expect to see common communication standards play a bigger role in IS. Apple already supports emerging standards, and we're working internationally to develop new ones. Today, many enterprises have adopted a popular open system for multivendor networking, TCP/IP. Macintosh fully integrates with TCP/IP environments. Thanks to products from Apple and third parties, Macintosh has kept pace with the fast growth of TCP/IP networks. Connecting Macintosh to TCP/IP is straightforward. Snap in an Ethernet card, load TCP/IP software for Macintosh, and you're connected. And what are you connected to? A complete array of network services, everything from accessing Unix server files to support for Unix and Internet mail. And of course, TCP/IP services fully integrate with the Macintosh environment. You can cut and paste between applications running under TCP and local Macintosh applications. And everyone benefits from the intuitive, consistent Macintosh approach to TCP/IP networking. At the investment banking firm of Hembrecht & Quist, brokers use Macintosh to watch market moves over a TCP/IP network.
In our particular industry, the need for information flow and having that information immediately is the most important element in success. There's absolutely no complication with getting any of that information. I don't know what software interface with the hardware does, nor do I need to know. I'm just happy to be able to use the mouse and use a few keystrokes to access the information that I need throughout the day. I have various screens that access information on the market or portfolios, and I'm able to use that information interactively with our Telnet server. What you're seeing right now is a specific portfolio that has to do with a selected stock list for Hembrecht & Quist. Another feature and function that I use in particular is the Telnet news service, where I can paste information that comes across the Dow Jones Newswire directly onto a spreadsheet or a word processing document and fax that immediately, or print it up and send it to a different part of the office or to a client if need be.
With our environment where the market is moving and can be moving very quickly, and people can have money at risk and can lose money if the wrong decision is made, it's very critical that the system always be there and always be right. Hembrecht & Quist originally had Quotron, which is a system for monitoring the market that's based on terminals. And we wanted to replace the Quotron system in order to attain cost savings, in order to increase our flexibility, and in order to give the brokers productivity so that they could do other things besides just follow the market. The reason why we went with TCP/IP and Ethernet is that with the Ethernet, there's a lot of choices for hardware, and with the TCP/IP protocols, there are a lot of different choices for software. We have a Unix-based MIPS RISC computer that is our server, and so the server manages the communications lines coming in from the outside world, builds a database, does any protocol management or session management that's needed, and that is attached to our Ethernet backbone. And then we have, out across the Ethernet, we use TCP/IP to connect up all the Macintoshes. The Macintosh is an ideal client on our TCP/IP network because it's so easy to configure. You just plug it in and away you go. We've done all the wiring for every place there could ever be a network in advance, and then you do the Mac TCP configuration, which might take you anywhere from a minute to 5 minutes maximum, and you're up and running. All you have to do is pull down your control panel and access the Mac TCP configuration dialog and make your selections, and it's all right in front of you, and if you make a mistake or forget something, you'll be told immediately and you can correct that. a problem for our users in using a Unix machine is it is expensive. It's more expensive than a Macintosh. And with a Macintosh, you can get the same amount of performance as you would with a Unix workstation for these kind of applications that you need to do. And there isn't the availability of software with a Unix system for doing, personal productivity things. The Macintosh has every bit as much computing capability as any MS-DOS or OS/2 machine. And in fact, I think at this point in time, it's now cheaper in terms of the amount of memory that you need to run applications versus what you might need on OS/2. It's a very cost-effective solution and has every bit the amount of power that you would need.
We hardly ever get questions about the network that would require my support. I mean, the users themselves really don't know that it exists. They're not aware of IP addresses or anything that's in the control panel. It's something that they use, they get the information, and they're really happy with it. Since I don't have to spend so much time troubleshooting the network itself, and since it is such a good support for me, it enables me to educate the users and really show them how they can use the Mac to get a product.
With Macintosh on TCP networks, you can make more cost-effective use of workstations and host resources. Let's see what that means at Scripps Research Institute, where medical scientists access TCP networks around the world.
Scripps Research Institute is a large biomedical institution devoted to understanding diseases and how to help people not have diseases. My department is called neuropharmacology, which simply stated means how drugs act on the cells of the brain. The brain, of course, is the global network to beat them all. It's all connections there. And when we share our brains, when we share our brain power through the computer data access, that gives us a way to really use our smarts in a much more synergistic way. I don't have a lot of questions that demand the use of a Sun workstation or to take time off of the Cray. I need to be able to use them when I need access to them, and having the network makes it possible to do that.
But you can't have a large computer in every part of the laboratory. Instead, we have Macintoshes on desktops and on benchtops to connect into the larger machines. We can put all of the computers, almost like virtual terminals, onto the Macintosh desktop. We can have a Sun in one window. We can have the Cray in another window. Unix machines aren't simple and easy to use. The Macintosh is intuitive. That's how it was designed. It has a desktop that looks like your desk. Every Macintosh machine can use the TCP/IP services, from the classic up to the Macintosh 2FX. The three ways that we do it are through Telnet login services directly into a Unix host. The second way is through FTP file transfers from one machine to another. The third way is through mail services from the Macintosh to any other computer in the world. A lot of the data that other people use on other machines are stored under NFS. We can use the Macintosh computer to mount any NFS volume located on any computer on the network. If I'm mounting an NFS server located on a Sun machine in another building to this desktop, it appears as an icon right here, looks just like a disk. If I double click on that, I can open it up, and all of the files that are there appear as Macintosh icons, which can then automatically launch Macintosh programs, even though they're stored on a foreign operating system. Macintosh users can log into a mail host, such as one of our Unix machines. If they don't like that, they can use the Macintosh way, which is through QuickMail. We use QuickMail to connect to SMTP mail. A user simply has to type in his password, and he can read mail that's coming in from anywhere else on the internet to his machine. A lot of the data that we use in neuroanatomy here are stored in the form of images on other machines. We want to visualize that data and to be able to run programs that can analyze it. In order to do that, we then run a program on the Macintosh called MacX. You don't need to buy expensive X window terminals and workstations to look at the data that's stored on your X servers. All you have to do is buy a program and run it on your Macintosh. We have PCs here too, but 9 out of 10 scientists just won't use them. They refuse to use them. Macintosh is the machine of choice, and it's chosen for everything.
As we've seen, Macintosh is straightforward to use and to set up, and the customary TCP/IP solutions are integrated in the Macintosh user interface.
Now you have viewed this video, you've seen the added value the Macintosh can bring to multi-vendor situations. You've seen how it can enhance the productivity of individuals and the effectiveness of your organizations. We are confident we have shown you a closer perspective on some of the connectivity benefits the Macintosh can help you to achieve. However, a short video like this can only touch the surface of such a highly complex subject. For example, we have not dealt with the client-server concept. In our view, this and other aspects of the open system debate require more time for in-depth discussion of their many facets. As an MIS manager, I'm sure you will want to know more, not only about this topic, but about how you can achieve maximum benefit for your own organization. So I'd like to invite you to a seminar we are holding in January 1992, the Apple Enterprise Forum on the Macintosh in multi-vendor environments. The Apple Enterprise Forum will be held at the Sheraton Hotel in Brussels on January 23rd, 1992, and will give you the chance to meet 4 brilliant speakers. The forum starts with a world-famous consultant's viewpoint on the important developments taking place in the computer industry. Drawing on this, you will have an opportunity of hearing more about Apple Computer's future directions. Finally, the forum will show some highly topical Belgian cases where the Macintosh is proving effective connectivity capabilities. So please, make a note in your diary now. January 23rd, 92 is the day to remember. And please use the fax reply sheet today to get full details of the Apple Enterprise Forum and your personal invitation. We'll take care of the rest. Finally, I'd just like to say thank you for giving me your time and attention these past few moments. I hope you will be able to attend our seminar in January 92, and I look forward to be with you there.